Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Phistomefel Spiral by Oatmeal. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have digits along an arrow sum to the digit in the attached circle. So for example, say you had a 3 and a 5 here, then this would have to be 8 because the digits along the arrow must sum to the digit that's on the circle that's attached to it. So, for example, these 3 and 5 would have to add up to 8, and therefore that's why this circle would be an 8. We have digits in a quad circle must appear in the 4 surrounding cells. So, for example, if around this quad circle there must be a 1, a 2, a 3, and a 5 in one of the cells that surround this quad circle. Because the 1, 2, 3, and 5 are all in the circle that signifies that. And finally, we have digits separated by a white dot are consecutive, and not all dots are given. So for example, if this were say a 6 here, this would have to be 5 or 7 to make sure that these digits are consecutive. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. So because of the, well, we're going to be using Phistomefel's ring theory based off of the title of the puzzle, which is Phistomefel Spiral. And it seems to work very well in this situation, particularly because we have quads around the corner 2x2 areas. So, let's get a recap. What is Phistomephel's ring theory? Phistomephel's ring theory is that the digits that surround the center box in a normal Sudoku puzzle, the 16 cells that the 16 cells that surround the center box must contain the exact same digits as the 16 cells that are in the 2x2 corners of a normal Sudoku box or normal Sudoku grid. So basically that these digits here, if I can not misclick here, these digits here must be the exact same digits. Sorry, the digits in these cells must be the exact same digits as the digits in these cells, essentially. And here's a quick proof about how this works. Say we have, we take a look at rows 3 through 7. What are the digits that are going to be in this rows 3 through 7? You have to have 5 sets of the digits 1 through 9, right? Because we know there's no repeats in any row, column, or box, or designated 9-cell region. And because of that, you have to have 1 through 9 in each row, which means there are 5 sets of those in rows 3 through 5. Now, what happens if we remove the center box from that? Well, that's one set of the digits 1 through 9, right? Because remember, every row, column, and designated 9-cell region, which in this case is a box, contains a set 1 through 9 without repeats. So that's one set we remove if we remove the center box. So that's 5 sets of the digits 1 through 9 minus one set of the digits 1 through 9, which gives you 4 sets remaining of the digits 1 through 9. Now let's take a look at the columns 1, 2, and columns 8, 9. What are the digits in those, in that combined set? It has to be 4 sets of the digits 1 through 9, right? because it's 4 columns. And again, there are no repeats in any column. So therefore, you have 4 sets of the digits 1 through 9 in the green region and 4 sets of the digits 1 through 9 in the orange region. Now, there's some overlap in those regions, right, which are these 10 cells here and these 10 cells here. So those are exactly the same digits. Or yeah, they're exactly the same digits, right, because they're the same exact cells. So if we remove those will be removed from both the 4 sets in the green region and the 4 sets in the orange region. So therefore, because of that, we're removing the exact same digits here for both of those regions. Therefore, these digits must be exactly the same as these digits here, right? Because again, they both contain 4 sets of the digits 1 through 9, and then you remove the digits, the cells that were in common. Because they were in common, they necessarily had to have the same digits removed, right? And because they're both essentially 4 sets of the digits 1 through 9 minus the common removed digits, that means the remaining digits have to be exactly the same. And that's basically the proof of Phistomeffel's ring theory. So how do we use that? Well, we know in these quads, the 4 digits in the circle must be in the 4 surrounding cells, right? Because there's no other place for them. One of them has to be in each of the cells. There's 4 cells required to be around the quad, and there's 4 cells available in the quad. So therefore, this must contain 1, 2, 3, 4. This must contain 1, 2, 3, 5. This must contain 1, 2, 3, 4. And this must contain 1, 2, 4, 5 surrounding this. So therefore, this green set can only contain the digits 1 through 5, right? Because those are the only ones available in the 2 by 2 corners. So these must be 1 through 5. These must be 1 through 5. And because of that, we know 1, 2, 3, 4 in this upper left-hand box have to surround the quad. So then this can't be 1, 2, 3, or 4. It must be 5. Same with this set. We have 1, 2, 3, 5 surrounding this quad. So therefore, in the rest of this box, you can't have 1, 2, 3, or 5. So this is 4. Around this quad is 1, 2, 3, 4. Which means this can't be 1, 2, 3, or 4. So it's 5. And around this quad is 1, 2, 4, 5. So around this quad, you cannot have 1, 2, 4, or 5. So this is 3. This obviously removes 3 and 5 as possibilities in the rest of the column. This removes 4 and 5 in the rest of the column. This removes 4 and 5, and this removes 3 and 5. So if you take a look, you now notice that these digits we have are exactly the same now. Of course, they're obviously the same because we've already made that assumption. But anyways, so this gives you a lot of information about the puzzle and restricts that information. So the remaining digits in the corner boxes must be 6 through 9, right? 6 through 9. This is 6 through 9. We have 6 through 9 here. And this is 6 through 9 here. Okay. Now we just restrict things even more by certain aspects, like, for example, this cell plus that cell must equal the same digit as that cell. So this can never be 9, and this can never be 6. Same with this. This can never be 9, this can never be 6, because... and this can't be 4. 4 plus 6 adds up to at minimum 10, which is not a digit. So we know 4 has to appear in one of these 2 cells here. So this is either 4 and 1 adding up to 5, or 4 and 2 adding up to 6. Okay. 7, 8, 9 is consecutive with 6, 7, 8, 9. This is 3, and this digit is consecutive with it. with this cell. So this has to be 5 through 9 here. Well, what are the possibilities here? This cannot be 7, 8, or 9 because 7 with 3 at minimum adds up to 10, which is not a digit. So therefore, this can only be 3 with 5 or 6, which means this adds up to 8 or 9 here. So 5 or 6 is consecutive with only 6 or 7 out of the remaining 6, 7, 8, or 9. And we have a 5, 6, 5, 6 pair then in row 6, which eliminates 5 and 6 in the rest of the row. This cannot be 5 or 6. So then what can these two digits add up to? If you have 4 here, it would necessarily force this to be 4, 1 or 4, 2, which adds up to 5 or 6, but that's not possible because of the 5, 6 pair in the row. So you cannot have a 4 here, which means this is a 1, 2 pair adding up to 3. And this 1, 2 pair eliminates 1 and 2 in the rest of the column, so this must be 4. This 3 eliminates 3 here. Where can 1 and 2 appear in row 6? It cannot appear here because of the 1, 2, 3 triplet in the box. Can't be here, can't be here, can't be here. So it must be in this cell here as the remaining 1, 2. Well, that means the remaining digits in row 6 must be 7, 8, or 9 because of the 1, 2 pair and the 5, 6 pair in the row. So 7 has to be one of those two there. What are these digits adding up to? It cannot be 1, 2, and 1, 2. So if we have a 3 here, that would guarantee this is 1, 2, 1, 1, 2, which would force this to be 3, which is the same digit as this one, which is not allowed. So we have to have a 3 here, which means this can't be 3. To add up then, this has to be 4 or 5. This can't be 1, 2, and 1, 2, and 3 can't be here anyways. So this must also be 3 with 1 or 2 adding up, which means it's 4 or 5. Well, we have a 4, 5, 4, 5 pair in the center box, which eliminates 4 and 5 in the rest of the box. So this can't be 5. This is 6, which makes this a 2, 4 pair to add up to 6. Which means we eliminate 2 and 4 in the rest of the row. So this can't be 2. That's 1. And 1 cannot be here because of 1 in the column. We also have a 1, 2, 4, 5 pair in row 4, which eliminates 1, 2, 4, and 5 in the rest of the row. This also can't be 3 because of the 3 in the box. So cannot be 1 through 5 here. This could be 6 or 8. Cannot be 7 because the 7 is required to be in one of these two cells in that box. So if this is 1 and 6, that would be 7, but we can't have a 7 there. If it's 2 and 6, so this can't be 7, this is then 8 or 9 to add up to with these two cells. We have a 7, 8, 9 triplet now in this box, which eliminates 7, 8, and 9 in the rest of the box. This can't be 8, so this is 6. And you can't have 1 and 6 add up to 7, so this must be 2 and 6 adding up to 8. Which eliminates 8 in the rest of the box, so this becomes a 7, 9 pair. This 7, 9, this 2 eliminates 2 here, so that's 1. 1 and 3 add up to 4, so therefore this must be 5, which makes this 2 and 3 to add up. And that eliminates 2 and 3 in the rest of the row, so this is 1. The 7, 9 pair eliminates 7 and 9 in the rest of the row, so this cannot be 9, this is 8. 8 plus 8 is equal to the sum of 5 plus 3. And we know 5 is only consecutive with 6 or 7 out of 6 with... It's only consecutive with 6 out of 6 or 7. So this is 6. This cannot be 6 or 8 anymore. This can't be 6. This 5 eliminates 5 here. We have a 1, 2, 3, 4 quadruplet in column 2, which eliminates 1, 2, 3, 4 in the rest of the column. Where can the 8 be? 8 cannot be here because of 8 in the box, so 8 has to be here because it can't be any of these cells here. So that leaves a 7, 9 pair remaining in column 2. We know the 3 in column 2 has to be one of these two cells. So 3 is consecutive with only 2 or 4. So we know 3 is guaranteed here, therefore 3 cannot be here in the same box. 3 is only consecutive with 2 or 4, so we have a guaranteed 1 here, which means this cannot be 1. 8 eliminates 8 here, and 8 eliminates 8 here in the box. So what can this be consecutive? 1, 6 adds up to 7, which works. 1, 7 would add up to 8, but we can't have an 8 there because of 8 in the box being there. So this must be 7 and 6, which makes this 9. That eliminates 7 from the rest of the column, so this is an 8-9 pair, which eliminates 8 and 9 from the rest of the box, so this can't be 9. Therefore, this is 7. That eliminates 6 and 7 here, so this becomes an 8-9 pair, which eliminates 8 and 9 in the rest of the box, so this must therefore be 7 and 6. That eliminates 6 and 7 here, which eliminates 8, which gives us an 8-9 pair, which eliminates 8 and 9 from the rest of the box. This 6 eliminates 6 here. So this is 7, which eliminates 7 here, so it's 6. This 7 eliminates 7 here, so it's 9 and 7. 9 eliminates 9 here, so it's 8 and 9. 7 is only consecutive with 6 or 8 out of 6, 7, 8, 9. And this 6 here eliminates 6 in the rest of the column, so this is 8. 8 eliminates 8 here, so it's 9 and 8. Okay, 1 here means this can't be 1 here, so this is 2, which eliminates 2 in the rest of the column. This can't be 2, it's 3. This can't be 2, it's 4, which forces 2 to be here and here. 2 here eliminates 2 here, so it's 1 and 2. Okay. Remaining digits in this left central box are 3 and 6. 6 can't be here because of 6 in the row, so this is 3. 3 can't be here, so therefore it's 6. Remaining digits in this right central box are 4 and 5. So that's fine. Remaining digits in the central box, well, where's 1 in the central box? Can't be here, can't be here, can't be here because of 1's in the rows and columns, so it has to be here. That leaves us 7, 8, and 9 remaining in the central box. And this can't be 8, and this can't be 8 because of 8 in the row and 8 in the column. So therefore, 8 in the central box must be here. Okay. These digits are consecutive, so they can never have a 5, and they have to have a 2 here to be consecutive with each other. 2 and 1 and 2 and 3. Therefore, 2 cannot be here. 5 is one of these cells. Since 2 can't be here, that eliminates 2 in the rest of the row. So 2 has to be one of these two. Well, we have a 1, 2, 3, 4 quadruplet in row 1, which eliminates 1, 2, 3, 4 in the rest of the row. So that leaves us with 5, 6, 8, or 9. And this can't be 5 or 8 because of 5 or 8 in the column. This can't be 6 or 8 because of 6 or 8 in the column. So where is the 4 remaining in row 1? It has to be one of these two digits here, which eliminates 4 in the rest of the box. We need 5 to be in one of those cells. So, where can 4 be then in row 2? It has to be in this upper central box because it can't be here. Again, because in row 1 we need a 4 in one of those two cells, so it can't be there. And it can't be here because of the 4 in the box. And if this was 4 here, we are guaranteed 5 cannot be with it. We're guaranteed 3 cannot be with it, so it cannot be in the consecutive cells. So it has to be here. So this is 4. And we have no 1, 2, 3, or 5, so this has to be 7, 8, 9 remaining. And because it must be consecutive, it has to be 8 with 7 or 9. And so this has to be 8 here, which eliminates 8 from being here. So this is 9, this is 8. 9 eliminates 9 here, so it's 7 and 8, that's consecutive. 7 eliminates 7 here, so it's 9, which eliminates 9 here, so it's 7. Which eliminates 7 here, so that's 9 and 7. So no more 8 here. This 9 eliminates 9 in the rest of the column, so this is 5. No 5 here. Remaining digits in column 6 is specifically a 3. So 3's here, which eliminates 3 from being one of these two cells. We have a 1, 2, 4 triplet in row 8, which eliminates 1, 2, 4 in the rest of the rows. So this cannot be 2 or 4. It's 5. And 5 is only consecutive with 4 out of 1, 2, and 4. So this is 4. This cannot be 4 here. So this is a 1, 2 pair, which eliminates 1 and 2 in the rest of the box. Which digits are consecutive here, then? It has to be 3 and 2. Because 1 and it's not consecutive with 3 or 4. And 4 is not consecutive with 2 or 3, or 1 or 2. So therefore, this must be 2 and 3. That's 3 in the corner. We celebrate because we know we're close to solving this. This can't be 4 because of 4, and this can't be 5 because of 5 in the box. So this is 2, and this is 1. 2 eliminates 2 here, so this is 1. 4 here eliminates 4 in the column, so this is 3, which makes this 2 to be consecutive with it. 1 forces this to be 4 here. This can't be 2 or 3 because of 2 or 3 in the column, so this is 1, which is only consecutive with 2 out of period. This can't be 1 or 3, so it's 5, which eliminates 5 in the rest of the column, so it's 4 and 5. That leaves this digit as 3, this digit as 1, and this digit as 4. And the rest we fill out with normal Sudoku. We have remaining in row 8, 7, and 9. This can't be 7 because of 7 in the column, so this is 9, which makes this 7. 9 eliminates 9 in the rest of the column, so that's 6. That's 6 there, and then 9 there. And that leaves this digit as 6 and this digit as a 5. And that's a solution. So, yeah, fairly straightforward if you know Phistomeffel's ring theory. If not, though, it's not going to be easy for you. I always not sure how to rate these because it's simple if you know the trick to basically get the break in. But if you don't know the trick, it's going to be pretty hard, right? I don't know. I guess I would always rate it a little harder than normal, so I would probably rate this easy then, if that's the case. But you are given the hint of the Phistomefel spiral, so I don't know. Maybe it's maybe it is very easy then, because if you know it, then if you see the title, you'll know exactly what to do. I mean, it's pretty obvious too if you know Phistomeffel's ring theory. It's like, oh, we have quads specifically around the corners, the 2x2 corners of the grid. So, anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.